In this tutorial, we're going to show you how to run a decision tree model on PySpark on a set of data. The data set that we will be using is boston50.txt. It's a sample data set, and its main purpose is to be used for classification, which is what a decision tree model does. So what we're going to do here is we're going to import anything necessary to run this model. So we have Spark context, pipeline, a couple decision tree model functions that we're importing, or libraries that we're importing, MLUtils, which is the machine learning library, and labeled point, which helps with the regression. So we'll run all of those. And in the next section we'll be selecting the data set. So if this isn't where the data set is located on your local machine, then you'll need to change this information in this file path, and then we'll cache it afterwards. So the first thing we're going to do after this, after we have our data set in, is we will be replacing the tabs with commas, as our current file is tab delimited and we would like it in comma format. So we'll use the map function to do this. Okay, and next we are going to create our own function. So this is going to be a user created function, and we'll name it parse point. And what it will be doing is going through each line. Later it will be called using a map function, but it will be used to select the predictor variables in our data set as well as the outcome variable. So first what we'll need to do is split each line, and then it will return a labeled point. So the values in column number 13, so our 13th variable is going to be our outcome variable, and then we will specify all of the predictor variables. So that will be 0 up to 13, so 0 through 12. We'll run that, and then now that we've created that function, we will call that function using a map. Press enter. So the next thing we want to do to test the model we're going to create is create or subset two different parts of our data set into one training data set and one test. So we'll create those two variables. And this we'll call parse data, and then call a random split function. And we'll take 60% of the data set and put it into our training, and 40% of it and put it into our test. And run that. So the next thing we'll want to do is finally create the model. So this decision tree library has a function, train classifier. It's fairly self-explanatory. It will take in your data and create the model. So we're going to take our training data set, and the number of classes equals 2. If you're using a different data set, you'll want to look into that column to see how many different outcome variables there are, or how many different classes there are. In our data set, it's either a 0 or a 1, so we only have 2 classes. The categorical features info, that's additional information that you may know about your model. It allows you to be more specific. However, it requires you making certain assumptions about your data. So the next thing we'll have to put in here is the impurity. This is the default version, and what the impurity measures is essentially it measures the quality of how the model is split using the decision tree. And the max depth and the max bins are both measures. These are both default as well, but they are measures that that tell the decision tree how to split the data. Okay. So using the model that we created, we're going to test this on itself. Really, we're going to use the training data here to test how well it worked. So prediction. This x.features will call the result of the model. Nope, training Boston. Okay, next we'll be combining the labels and the predictions for that training set. So essentially it'll be combining what labels that there were in the original set and then what predictions came of it. We're just going to eventually test how accurate this model was on the training set. And we're going to call zip to add the prediction. What we're going to be doing here is we're just going to be counting those predictions that were wrong, which will help us figure out the training error of this training set, this data set. So where v does not equal p, and then we want to divide it by the total out there, or the total number of observations we have. Labels and prediction. And then after we create that, we can print the training error. Very small error, so it looks like it's done a good job so far. However, we now want to test this on the rest of the data set. So this has only been tested on the training set so far. So now we're going to move it to the test set that we created earlier. So we're going to call the same functions as above. So here we're going to take the test set and then map. So next we'll want to do as we did above and just create, we're going to create a model accuracy here rather than the training error. So here we want to call it where the value is equal to the prediction and keep those observations. And we're going to count the total number of those and divide it by, again, the total number of observations. Count j. And the last thing you have to do is print the accuracy to see how well it did. And the model came up with roughly an 84% accuracy.